Woohoo! We're going to be working on section 6.8, which is chock full of word problems and your favorite fractions. Yay! And because we are dealing with fractions, I brought in my two favorite carnivores, my shark and my sharktopus. You know, they are related if you look at the evolution. And, well, at least according to Sci-Fi Network. I'm also going to have my calculator nearby whenever I'm working with fractions. But what I wanted to do first was talk about when you're allowed to use decimals, because decimals seem like everybody's best friend, right? Fractions, they're just coming, they're bullying you, they're making you feel bad about yourself, and then you're like, oh, decimals save me. And the answer is decimals, yes, can save you, but also can cause other problems with rounding. So let's talk about safe fractions and other fractions. This is just my terminology. So, part one, when can you use decimals? It's a good question. So, the answer is you can rewrite a safe fraction as a decimal anytime because they are exactly equal. Other fractions, the other ones that are not the safe fractions, you can only rewrite them as decimals at the very end of the problem. Basically, if you use a decimal approximation in the beginning of a problem, the little tiny rounding that you do then, by the end of the problem, can be massive. You can be completely off of the correct answer. So this is going to be super fun because what I'm basically telling you is that for the fractions you most love to hate, you have to work with them as fractions. But the silver lining is you're going to get some more practice with fractions. Who doesn't want that? Yay, fraction. Fraction practice. Not easy to say. Okay, fraction practice diction. There we go. So part two, what the heck is a safe fraction? Well, safe fractions are those fractions which when you convert them to decimal, are terminating decimals. Now, I know terminating makes us all think of those movies and Arnold Schwarzenegger, and I really wish I had an Arnold puppet right now. You're just going to have to go with the Sharktopus instead. But basically, if it's a terminating decimal, it means it stops. It just, 1/2 is 0.5, and that's it. That's everything. You've got all the information right there. So these two are actually equal. And there are a bunch of fractions that work that way. 1/2, 1/4, 1/5, 1/8, and 1/10. So more than half the denominators that you could consider are going to be really, really friendly, at least up until 10, right? There are a lot of other, we'll talk about those later. Don't panic. What? There's a pterodactyl. Just ignore it. So 1/2, 1/4, 1/5, 1/8, 1/10, or pretty much anything in the numerator over these guys will also work. Those are all going to be safe. You are welcome to convert these to decimal at any time. You're just like, you know what? Fractions are great, but I want to do decimals now. Awesome. These are all safe. These are exact values. We're very happy. Okay, let's look to the other fractions. The other fractions are non-terminating decimal equivalents. So basically 1/3, if you think about it, it's 0.333333. Unless you have a lot of time, technically an infinite amount of time, you can never include enough decimal places. There's just no way. You have to keep writing it forever. So wherever you decide to stop, which a lot of people are like, well, let's just put 2 3s in. Well, you're missing a little bit from that next 3 that should be there, and then the 3 after that. So you'll notice this is a wiggly equals. They're not equal. So these two cannot be interchanged for each other. Now, at the end of the problem, when you're very done, when you're very finished at the very end, sometimes you'll go ahead and convert it, just because a lot of times decimals are easier to understand than fractions. So 1/3, 0.333333, etc. This is an approximation. Do not convert this in the middle of a problem. 1/6 is 0.166666666 forever. The 7 is just a rounding, so you're going to have a little error there. 1/7. Oh my gosh, I don't even remember this one. This one just, it bops around all over the place. It's 0.14 something. And again, you can always check. Oh, look, I've got it right there. You just do 1 divided by 7, and you can see there it's 1 0.142857143, and my guess is it probably is actually going to repeat, but I don't recall off the top of my head. Fun activity with the kids, do a bunch of divisions. Try long division of 1 divided by 7. See where it goes. I mean, seriously, kids love math. And then, well, kids hopefully will love math. 1/9 is 0.111111111, but again, it keeps going forever and ever. So anytime you write out a decimal approximation, unless you are, an infinite being that transcends space and time, in which case, nice and lovely to have you in the class. But for the rest of us mere mortals, we do not have time to include enough information here so that we can use these values in our calculations. So what you're going to see in this chapter is you're going to see me using the fractions and waiting till the very end before I even think about a decimal. Okay, thank you so much. So let's get into the problems. Woohoo! Let's get into the bunny fur. Woohoo, bunny fur. Okay, so we're going to start off with distance equals rate times time. D equals RT, dirt. And that can be generalized to quart. Quantity equals rate times time. And I've written it there, quantity equals rate times time, quart. This isn't the form we're generally going to use, though. We're going to divide both sides by t to get this interesting little guy. So I'm going to write right over here, if I have Q equals R times t, if I divide both sides by t, and get my red pen of destiny here, I can cancel the t's on the right, and then I get Q over t equals R, or, pardon me, Sharktopus. I'm going to move Sharktopus. He's just here. He's, anytime you have word problems, definitely keep supportive friends, supportive animals, your delicious snacks and your drinks, keep them close because, these things can be stressful, but we can totally get through it. And then I'm going to rewrite this equation. I'm going to flip it around, and write it as R equals Q over T, rate equals quantity over time. That's going to be the magic, the magic equation. Next question, how the heck do you recognize that we're in this land? Because you'll remember a few chapters ago, we had distance rate time and quantity rate time problems. How do we know that suddenly we're in fraction land? Well, one of the tip-offs is I'll give you a problem like a crew can drywall a house in 6 days. So you know the time, how long it's going to take, but you don't know how fast they're working. And if I'm asking what is their rate or how fast are they working, you're using this equation, the R equals Q over T, which means you're going to have fractions. Yay, fractions! Okay, so number 1, a crew can drywall a house in 6 days. So it's one house, 6 days. The rate equals, remember rate equals quantity over time. I don't have a cute way to think about that. If you guys think of it, let me know. My brain is trying to come up with one, and I don't know. My brain is just throwing out random words, so I don't think that would be helpful. So, but let's look at quantity is one house. They're going to put drywall on one house, and it's going to take 6 days. So their rate is, and I totally ran out of room. Oh no. 1/6 of a house per day. Sorry, it got a little smushy and I went off the side. So what the heck am I talking about? If you have house on top and days on the bottom, you just separate the number, so we get 1/6. And again, this is one of those non-safe ones, so I'd have to leave it as a fraction. 1/6 of a house per day. And remember, per means divided by. So the house per day. Okay, so that was number 1, 1/6. Woohoo! Let's look at number 2. One crew can drywall a house. So we're drywalling houses today. Different crew. This crew can drywall a house in 4 days, so they're faster. right? This crew took a whole 6 days. This crew took 4 days. We could talk about why. Maybe it's a bigger crew. Maybe it's they're not doing as careful a job. I don't know. One crew can drywall a house in 4 days, and another crew can drywall the same house in 5 days. How long will it take them together? Now, a lot of people want to just look at it and go, oh, well, together it'll take them 4 days plus 5 days, 9 days. And the answer is, well, if you think about it, if one crew can do it in 4 days all by themselves, then if the second crew helps, even if they're not very good, hopefully it won't take more than 4 days. I know if you've ever had help from somebody, sometimes things take longer when someone helps. But we're going to assume that these are professionals and they know how to integrate, so they're going to actually get faster. So, crew number 1, by which I mean, let me go with blue. We're going to talk about the crew that can drywall in 4 days. So this is going to be crew number 1. And remember, the rate equals the quantity over the time, which is a house. Remember, that's the sneaky thing. It's one house over 4 days. Just like up here, except I got smushy. 1/4, I pull the fraction out, and then I write of a house per day. So basically, they get 1/4 of a house done every day. So after 4 days, so 2 days is 2/4, 3/4, 4/4, the whole house is done in 4 days. Crew number 2, let me come up with a contrasting color. Another crew can drywall the same house in 5 days. So again, you're all thinking, well, wait a minute, how do we know? Well, let's just assume they're doing like a whole construction project where all the houses are exactly the same. So that's why we can actually do this. We've got rate equals quantity over time. And if you're thinking to yourself, wow, why are they making me write this formula over and over again? It's almost like they're trying to trick me into learning it. Ha ha, blah ha ha. Okay, one house takes 5 days is 1/5 of a house per day. And I know fractions are tricky because, your brain is used to seeing a bigger number means a bigger value. But with fractions, literally, it's turned upside down. So a bigger denominator is actually a smaller number. So 1/4 of a house per day versus 1/5 of a house per day. The blue team is going faster. Okay, so now here's where we're just going to take a deep breath. You ready? So there are as many ways to approach this problem as there are people, I think, because these problems are a lot more complicated than the ones that we did before. And I've tried a bunch of different methods, and the method that I like the best, the method that seems to be most consistently understood, looks like this. I'm going to say, let's say that it will take T days working together. And here I am going with it's very traditional to use a lowercase t for this, but you can use any letter you want. You could use a flower, happy face, whatever. Okay, so it's going to take T days working together. And so I'm going to have the first crew and the second crew. And I'm going to go ahead and assume, because I can't possibly know if they have like any interactions. So I'm going to assume crew 1 starts on one side of the house, crew 2 starts on the other side of the house, and they just kind of work together. So there's not any overlap. The reason for that is I don't know what it would look like if they overlap. I don't have any information about that. So I have to approach this with them working separately. So they start on opposite sides of the house and move together. Or they go to the top and come to the middle. However you would like to do your drywall. And I'm going to say that crew 1 plus crew 2 working together, crew 1, whatever they finish, plus crew 2, whatever they finish, for them to be finished, it has to be one house because they're working together on a house. This is going to be our basic setup. These two things, this is the model we're going to follow. So it's a little bit different than what you may have seen elsewhere. And if you have another way to do this and it makes sense to you, then oh my gosh, use that method. Okay, so crew number 1, how much are they going to finish? Well, they're going to finish their rate times their time. Right? Quantity equals rate times time. Where's my little thing? There we go. Quantity equals rate times time. So they're going to work their rate times their time. Crew 2 is going to work their rate times their time. And I'm going to get 1. Now, what is crew 1's rate? Crew 1's rate is 1/4. So they're going to do 1/4. And how long are they going to be working? Well, it's going to take T days working together. We're going to assume that they're going to both work exactly the same amount of time. See there? So it's 1/4 times the time. Plus, now crew 2 does 1/5 of a house per day times the time. And that whole thing equals 1. So take a look at that. And obviously, if we were in class, you could ask me questions. We're not, but you can always stop the video right now, go ask me questions either in Pronto or email me, come to my office hours, because I realize this is some weird, different stuff for a lot of people. This is not simple and obvious. That's why I go over this so slowly. Well, hopefully it's slowly. Okay, but once we've got this set up, then we've got an equation with fractions. That's it. So we say, okay, so this is going to be t over 4 plus t over 5 equals 1. Okay, awesome. So then I need to make a decision. Either you are going to work with the fractions or you're going to clear fractions. I personally am going to clear fractions. So I'm going to have t over 4 plus t over 5 equals 1. Now, for some folks, we've talked about it in office hours and in other settings. I'll remind you, if you haven't talked to me about it, sorry guys, my carnivores are standing by ready to eat any fractions, yum, 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 that get in my way, right? If they really give us trouble, you can always just have your puppet eat the fractions and take a break. Okay, so I have mentioned to a lot of folks that one of the keys to working with fractions, especially if you don't like them, is to write really, really big. So you'll notice that I'm taking up 3 lines with my fractions, right? There are 2 basic ones, and then these are kind of sticking over a little bit. Use lots of space. Do not try to write really small. Really small means you can forget things. So let's go ahead and let's see. I've got an LCD 4 and 5. There's no overlap between those two. So I'm going to go ahead with 4 times 5 is 20. So let me go in with my least common denominator, 20 over 1, 20 over 1, and 20. And remember, the reason I'm doing this is so that I can clear my fractions. If you don't care, if you don't mind the fractions, just work with the fractions. These two, you can add these. You can come up with a common denominator and add them together. And a lot of you may have already done that. And if you can do that, awesome. That's great. Do it that way. I'm going to go ahead and do it this way, where I've multiplied by 20 and by 20 and by 20. This one is a whole number because 1 is a whole number. And let's see, this 4 cancels with the 20 and I get 5. This 5 cancels with the 20 and I get 4. And that doesn't cancel at all, so I get 5t plus 4t equals 20. Ooh, nice. And then 9t equals 20, right? Because I can add those two together, no fractions anymore. Yay! And then I divide both sides by 9. And then t equals 20/9. What does that even mean? What does that even mean? So let's look back. How are we defining everything? Back it was 1/4 of a house per day, 1/5 of a house per day. It will take t days. So t is in days. So this is in days. Now's where a calculator comes in handy, because if you were, trying to get a job and you were bidding and you said it's going to take us 29 days, the person would be like, yeah, I'll call you. Don't bother calling me. So what can we do? Well, we can convert it. So you can convert this to a whole number. Remember, or not to a whole number, to a mixed number. Sorry about that. Remember, you do the 9 into the 20. 9 goes into 20 2 times. That makes 18. And there's a remainder of 2. So we get 2 days with a remainder of 2/9. Let me point out this 2. Ah! Oh no, I took you to Smearytown. Sorry. Don't you take me to Smearytown. I'm sorry I took you to Smearytown. Okay, so just circling these so you can, the first 2, because they come out as the same number, so it's hard to remember which is which. The number that you start with is going to be your whole number, and your remainder is your numerator of your fraction. So it's 2 2/9 days, and now this is, because ninths are those kind of fractions you only deal with at the very end. I'm going to do 2 divided by 9, and it's going to give me about 2.22 days. And that's an approximation. This is exact. This is an approximation. Or we've got one other option. What we can do is we can say 2 days, and then we take the 2/9 and we do, let's see, where do I want to, put question mark hours. 2/9 of a day equals 2/9 times 24. Why 24? 24 hours in a day. If I want to know how many hours, I take the total number of hours per day, and then I get, so I come over here, times 24, and that's going to be about 5.333 hours. ... Now, if you are a person who works in a day, where could my mistake have come up in this math? This is all correct for what I did, but I assumed that our day is a 24-hour day, right? 24 hours per day. What if you're only working an 8-hour shift or a 12-hour shift or a 4-hour shift? Well, then you would have to multiply times that. So I don't have that information. So where are we on the safety, our safety level? This is the absolute exact answer. 2 2/9, perfectly correct. 2.22 days, it's approximated because I rounded, so it's a little bit off. And then this, I had to make an assumption. It's 2 days and about 5 hours, but that's only if you consider a 24-hour day. And if it's a different kind of day, we'd have to find out more. So this is kind of like green, yellow, questionable. This is the best answer. But again, we're going to have to pay attention to the problem. It'll give us more information about how to consider it. Woohoo! Okay, so our video is now at 24 minutes. So I'm going to go ahead and give you guys a break. Go take a break, and then I'm going to come back and we're going to do more math. Yay! More fractions. Yay! Word problems. We love it. Word problems and fractions is the best. Woohoo!